Intro of myself. My name is Muhammad Tala Islam, and I am a student of Masters 2 Computer Science Engineering, Department of Polytech School, Sofia Antipolis. And I am working with Ma'am Dian in I3S Lab. So let's start. If you are a data scientist and you spend a lot of time building machine learning models, and you might familiar with the circumstances that your boss or your colleague asks you, how does your algorithm working exactly? How we can trust a model, right? I bet a very few of you have a simple answer for that, and your client is asks you that question because they spend a lot of money and on purchasing your model, machine learning model, and they want to know how decision has been made. So answer those questions. That is the motivation of my today presentation. Today, I discuss unify approach, interpret your model, and how we are going to apply to your real-time problems. The name of technique is LIME, and I present the top paper, Why Should I Trust You? Explaining the Prediction of Any Class, which is published in ACM Conference, KDD 2016. And in this paper, we are covered about the LIME techniques and the other details. And we take some examples and how the technique is worked. So everyone kind of know machine learning is everywhere. Started off being sort of emails. For example, I would emails are just go to the spam and you don't care. Even use in machine translations, even in the games in for example Go, AlphaGo, which is used by the reinforcement learning, is the example of this. Even in movies telling us what to watch, machine learning is in our homes, cars, pretty much is everywhere. So we don't care about this. And what is machine learning interpreter? What is it? Assume we all know what machine learning is. Loosely speaking, machine learns some math function based on some simple training data, and we output either a prediction or a decision. If you use simple math, for example, linear regression, I hope everybody is know about the linear or non-linear function. So for example, linear regression, it's really easy to explain to your client that how your model works. If consider if consider enterprise technology background, I would explain to my client, if age goes up, your market to your customer this type of field. So it's refer straightforward. However, our world is non-linear world. So the linear models such as logistic regression or linear regression doesn't produce such a high accuracy. So that unfortunate, and then we want to use a more complex model such as a deep neural networks model. Those models deliver a very high accuracy. However, it's operate in such a high dimension. It's so difficult to visualize it by human mind. So those model often refer as a black box model. So today, data scientists gave a trade-off that model accuracy and model complexity. So here on the slides, we have some data, and you want to reach at some application, and you train your model like any model, neural network, SVM, and random forest. Uh, and then from that model you get prediction, decision, or something. Now the main step which here is missing is, if my prediction is not make a sense, I get fired from my job. So this called a trust challenge. How my model behave, and in the real time problems. For example, I train my model on the prediction for prediction of weathers or something. If it's not working on my problem, so it's not useful for me. So how I convince to myself, or how I convince to my clients, and how I convince to my boss to explain them about nowadays neural networks are very popular. It's a challenge we obviously can't go expecting the reason. So they are very opaque. So this trust problem is really fundamental in a sense. Every time we deploy a machine learning model, and you are trusting implicitly, and it's been a studying a little bit, and there is a particular type kind of problem that we can face in our real time. So here in this slide, if I can if we look at machine learning, so first of all we discuss about the if we take discussion about the trust model. So here I take an example of Netflix faces, for example. uh, Not only do they have to trust the model themselves, they have to get us to trust it. So if I am going to spend 2 hours watching movie, I better have a good reason for it. So they do show a kind of explanation where they say you are going to like this movie because you like there are all the three movies that we also recommended it to you. So user trust in the system. So, if I take another example of a doctor, the doctor case is really similar to this case. For example, if you just tell a doctor, look, you have to cut this patient open because the model, so probability is like a 90%, the doctor is not going to do anything, and maybe we don't want it to. So another scenario, look to open this patient because they showed us some scenario, similar scenario or similar cases. So doctor use machine learning algorithm for a better decision. If if uh, if you understand model, it's easy to improve them. So if we understand what they are doing, we can fix problem and we can do better models. In this slide, what we do to gain the trust? How we gain the trust in machine learning? So in this slide, how we discussed already before about the interpretable model. Uh, so if I restrict ourselves to using a model that are very easy to understandable human, we already discussed about this. A very short decision tree, and this has a lot of information, is easy to understandable. For example, this is a very short interpretable and easy to understand what the model is doing in this scenario. For example, so that's why it's promising, but is not accurate enough because promising approach, but often we do this at the expense of accuracy. You cannot use neural network for this. And target part of it, that in order to make this model more accurate, we say one decision tree is not enough. We need thousand of tree for this. So another part of this, we gain the trust with the accuracy. How with the accuracy? For example, for the accuracy problem, to understand easily, we take a 20 news group subset data set, which is used for the machine learning, is like a standard data set. And we take in this paper, the authors are take a short part of the data sets like atheism versus Christianity. And in this slide, for example, this model is for example, we train a model on this standard data sets, and they give 94% accuracy prediction based on the email addresses, names, which can used in here. But when I use the same model in my real time problems, for example, when I test my data sets and my accuracy is 57% on my problem. So when I compare with the 94% accuracy of the previous model, and when I use the same model in my problem, it's not working. So this is the another example of trust challenges. So here in accuracy, if we can see the accuracy section is in authors is just target about the in this paper is data leakage, and in data leakage in machine learning is the problem. When you split your data sets in training and testing, be careful about your data is not shared. Your data is not shared with another data set, another folder. So this is like a data leakage problem. And another technique is A/B testing. In A/B testing, is just for example, in your company you have a 100 employee, you divide it into two groups, A and B, and then you test your trust or something. So it's a gold standard, but it's a very good, but it's a very expensive and slow. So in this paper line, the authors are target about the individual prediction, explaining individual prediction. We can discuss in the next few slides, and here what an explanation look. So we can take some here's some portion of the last example which we can discuss in the last slides. This is our text, and I can tell you about the another limitation of this paper is in this paper authors or target the text and images only. So in this example, uh, atheism and Christianity, the we see the accuracy is 94%. So when we see the prediction, and we can ask a question how it's solved, we can, because lime is taken explanation. So when we check the explanation, so we say Christianity, for example, C is capital, and Christianity is belong to Christianity, and uh, address, names, Keith and host, and the small first letter. So this is belong to the uh, this is the main issue. So this is not like generalized. So as a expert or as a non-expert, when I see the explanation, I am not trust on this model because this is a data leakage problem. So there are three must have a good explanation, interpretable. We can also in the start of presentation I explain in details about interpretable, and I again repeat, human can easily interpret reasoning, like if I see this a random forest as a human, I'm not understandable, but if I see the flow chart, or like this one tree is potentially interpretable. So another is I'm discussing about our in the line goal is trade-off between interpretable and faithful. So now what is faithful? Faithful is describe how this model actually behaves. Like we can discuss about the behavior of the model. For example, in this uh, so here we have a 2D example. For example, we learn our model, and we draw a line, but this line is not a faithful. So we don't finally we don't believe on this, and we don't use in our final prediction or final model. So, and a model agnostic is a model you can use any machine learning model. For example, in the starting, I'm talking about the black box. So as a black box means you take any classifier, you take any machine learning model which you can use for the problem. So you can explain the model's behavior. For example, you explain the neurons you on this for example on this layer, they take this input, this inputs, and just for the example to understandable, to explain each and every steps. So now we can move on the line, local interpretable model agnostic explanation. So we discussed before about and problem statement, motivation, introduction, and we take some example. Now we can move on the experiment section and some example which we can discuss before on the text. And now we move on the image sides. So the key idea: pick a model interpretable by humans. So for we take any neural networks model, SVM. Or any random forest model. But Lime is just target to the locally interpretable, not globally. It's not. This is again another limitation of the Lime. It's not globally faithful. Why? I explain in the next few slides, just in the few slides. And locally approximate, if we target locally, very good, and explain each decision like a local decision, so we can cover local by local and we achieve the global interpretable. So it's another good technique which we use and we say is a good technique for the learning. So uh, in the next slide, if we can move, if I see this image, 2D image, and this is a model which we can show is a very complex, is a very hard to understandable. So if I can take a local, if I can take a local, for example, here is a plus sign, and I just take this area, this section, uh, to understandable locally. So it's a good explanation for the prediction as compared to as a whole. I judge about the models and everything. So this is the explanation. For example, sample point. For example, we have a point like plus point, and use complex model to predict label for each sample. And according to the distance, learn new sample model on a weight sample. Use a simple model to explain. Interpretable representation. Now we have a model and we have one hot encoding system. We embed, for example, if I take the example of images, we don't store the exact image on our models. We take one hot representation in the text in the images, and that which can pass to the models. And I explain another things about the local and global. The difference is in local interpretable, because in local interpretable we use, if you have an idea about the BOW, bag of words. For example, we have a image. We have image locally is why I try to answer the question why locally, because if we have an image and we try to catch a patches, we extract the patches from the whole image, and then we using that patch to cluster that, and then we make a vocabulary, and then we can use for the, and in this we can store a local or neighborhood information about the pixels. So this is again a good thing, which if we can target and store a local information, it's we achieve a global information as well as very much good. So now we move to the uh, image sites, and this is my favorite part. And most algorithm we will do pixel based representation, where you have a 3 pixels per image and hard for humans to understandable. So what we do it, we break the image into the super pixels in on the right sides. Superpixel is just a group of pixel and that we use to explain, which is easy to understandable for the human. So we move to the again to the concrete example. This on the left side, this is our original image, is a tricky image because dog do not play guitar. But anyway, we want to get prediction on it, and our model predict dog in this picture is 21%, and we want to understand why. We on that image in a various way, for example on the instance of the images, and we do is hide the super pixel in the image, and we get images, and we get a prediction, and for the all guitars and dog, and so on, and these local regression information passed to the model to get the easily explanation. So now we move on the explanation side, and this is an example of Google in inception neural networks. Here we probability of a left of if left guitar is 32%, and prediction of the another type of the guitar is 24%, and for the dog is 21%. Here, train a neural network to predict a wolf versus the husky. Husky is a breed of dog. So when we train our model is predict wolf and dog. Basically, this is the game which play in the stadium, and from this, when what we know of one mistake, and if we go and we when we see this model, we have one question: do you trust this model? How does it distinguish between husky and wolf? So when we see the explanation of this model, we see the model is predict on wolf only with the snow detection, with the snow photo. So and without snow, they detect is a husky. So this is the problem. So we built a great snow detector. Now, did machine learning people notice that if before explanation and after explanation, this chart to compare with this, and if which we make the model in the last slide, they just make a comparison between that, and if we don't trust the model is like a 60% before explanation, and after explanation is a 90% they reject the models, and and other is the same. So now we evaluate whole model explanation, choosing between competing models. And I tell you one thing more. Lime is target the machine learning experters and non-expert of machine learning, like a non-technical person. So for this non-technical, we discussion about before this is a machine learning experters, and now we go on the non-machine expert side. So they go to the company is a mechanical turk, and they ask to the people whole model generalize better. So they ask to the people which model is good for the prediction, and they just click on the word and then realize. So I can explain in the next slide with the case study is very easy to understandable. So this is a competing model is just if you can just guess is a 50%, If the lime is accuracy is 75%, and with lime submodular 89% of non-technical person identify more trustworthy models. So if we pick based on the accuracy, we would get it wrong. For example, if in the previous of my slides, in the start of my video, I discussed about the doctor case. So this is the example. We don't believe on the accuracy. We just believe on the model that could be solve my problem is interpretable or faithful. So our main goal is trade off between faithful and interpretable. So fixed bad classifier. This we have a 20 news group data set, and we have a train and test folders, and we train our model on this data set and predict on the test, and then we explain to the uh, peoples like non-technical person which target in this paper, and they explain and they then evaluate the problem, and this process is cycling in the repeat. And now when the when this survey is passed to the non-technical persons, and they evaluate, and we get the information, like as author we get the information about which sentence is not important. So we make another hidden religion data sets. For example, they use the capital letters or something. uh, so we make a hidden religion data set which is hide from the user, hide from the user which who can use the main. So uh, they just click on the useless word for the task, and these tasks make maintain the hidden data sets. So this is the comparison. If we train on the 20 newspaper, and if we train, so just we in the start of the video I discuss about the one issue who is the leakage of data. So in this problem, lime is covered the all data mining problem, like one target which they can ask about the leakage data is covered with the lime. So conclusion is lime is trustable. So lime technique lime model goal is, does my model really work? What is my model doing? And how do I fix my model? Lime is give the answer of this question if you use any classifier. So thank you so much. If you have any question, you can